Hi guys, in this very class, we're going to be solving the fourth and the final question we are given as a take-home in our previous lesson on equations under modular arithmetic. Don't forget the fact that we've been working on modular arithmetic for some time, and in our previous lesson, we are given four major questions to get us tested. So we solved the first three questions, and in this very lesson, we're going to be solving the fourth and the final question. So for those that are just seeing this very question for the very first time, if you want to make an attempt, I'll advise you to pause this very video and make an attempt. Now we are asked to find the value of x in x squared plus x plus 1 equivalent to 0 modulo 49. In our previous lesson, we've solved the first three questions where we looked at various kinds of equations. So now how do we solve for x in this very quadratic equation? X squared plus x plus 1 equivalent to 0 modulo 49. Don't forget the fact that the first thing we're going to do is to use this very modulo to create a kind of table. We're going to get the multiplication table for this very modulo. So that's modulo 49. So that's going to be 49 times 0. That'll give us 0. So each of the multiples we get, we add it to this very, to this very remainder that we have here. So from there, we end up having our complete quadratic equation. Then we try to solve for x. So 49 times 0 is 0. 49 times 1 is 49. Let's get a couple of our multiples. 49 times 2 will give us 98. So let's try out this first three multiples. Let's see if you're going to get the value of x using this first three multiples. So we have 0. 0 plus 0 is 0. That's going to be x squared plus x plus 1. Equivalent to same as equals to 0. So how do we get to know if this equation is solvable or not? We're going to be using our discriminant. Now, discriminant is d equals to b squared minus 4ac. Now, what's the work of the discriminant? This tells us if the root of an equation is real or not real. So that is, if we put in the various coefficients, if we put it into this, and we get a result lesser than 0, less than minus something, it means we have an unreal, root. That root will give us a complex number result. So we're going to try to see, let's see if this is solvable or not. So a here is 1, b is 1, c is 1. So discriminant is b is 1 raised by 2 minus 4. A is 1 times 1. 1 raised by 2 is 1 minus 4 times 1 is 4. This is minus 3. So we're going to end up having a complex result. So let's try out 49. We're not going to use this. Let's try out 49. 49 plus 0 is 49. So that's s squared plus x plus 1 equals to 49. We send this to the other side. That's s squared plus x, 1 minus 49 equals to 0. S squared plus x plus 1 minus 49 is minus 48 equals to 0. So a is 1, b is 1, c is minus 48. So discriminant, 1 raised by 2 minus 4, a is 1, c is minus 48. D is 1 raised by 2 is 1, minus is plus. 4 times 1 is 4, 4 times 8 is 32. 2 keep your 3, 4 times 4 is 16 plus 3, 19. So the discriminant is 193. So if the discriminant is 193, it means this root is real. But don't forget the fact that if we use minus b plus or minus square root of b squared minus 4ac over 2a, that means you're going to get the square root of 193. So that is if you use the formula method. So the square root of 193 will give us some stars and decimals. So I don't think we're going to be pleased with this. So let's try out 98. Let's see if 98 is going to work. So that is s squared plus x plus 1 equals to 98 plus 0 is 98. Send this to the other side. So s squared plus s, 1 minus 98 gives us minus 97. So we try out the discriminant also, that is b is 1, a is 1, c is minus 97. So that's 1 raised by 2 minus 4, 1 times minus 97. So 1 raised by 2 is 1, minus and minus is plus, 4 times 7 is 28, 8 gives you 2, 4 times 9, 36 plus 2, 38, 1 plus 38 is 389. So if we use the formula method, minus b plus or minus square root of discriminant, 1 plus 389 is 3, 1 plus 388 is 389, I beg your pardon. The square root of 389, let's see if 389 is a perfect square. 389, 1, 1 times 1, the long division method to get square root. So yeah, 89, 1 plus 1 is 2. If 1 plus 1 is 2, defeats your 7, 7 times 7, 49, 214, 189. So if you try out, let's say 9, put your 9 here. So 9 times 9 81, 9 times 2, 18, 261. So this will not give us a perfect result. So that means we're going to keep trying. Let's try 49 times 7. Let's see what we're going to have. 49 times 3, 49 times 4, times 5. Let me try 49 times 7. 7 times 9 is 3. I have 3 keep your 6. 7 times 4, 28 plus 6, 34. We have 3 for the 3. So 3 for the 3 plus 0 is 3 for the 3. So that's s squared plus x plus 1 equals to 3, 4, 3. So we're going to send this over to the other side, to the zero side, from the right hand to the left hand. That's s squared plus x plus 1 minus 3 for the 3 give us minus 3 for the 2 equals to 0. So we're going to be using the same discriminant that tells us the kind of roots that we have. That tells us if the root is real or not real. So a is 1, b is 1, c is minus 3 for the 2. So the discriminant b is 1 raised by 2 minus 4, a is 1, c is minus 3 for the 2. So 1 raised by 2 is 1 minus, minus is plus, 4 times 3 for the 2, 4 times 2, 8, 4 times 4, 16. Just keep your 1, 4 times 3, 12 plus 1, 13. That's 1, 3, 6, 9. So that's a real root. Let's see, we're going to get the square root of this. By the time we get the square root of this, let's see if we're going to get something whole or we're going to get some decimal fractional stuffs. So 1, 3, 6, 9, we're going to be using, let's use our long division table also. Let's use this. So share this into two parts, 13, 6 to 9. You can use your calculator easily to make this very quick. So 3 times 3, 9, 4 times 4, 16. 16 is bigger than 13. We're going to use 9. 10 of 9 is 3, and 3. 3 times 3 is 9. 3 plus 3 is 6. 13 minus 9 is 4. Bring your 6 and 9 down. So the question is, what are we going to add to this and add to this? We've worked on these already in our previous set of lessons, many lessons ago. So let's, if you try out 3 times 3 gives us 1, it's 9. No, it's far from this. Let's try out 7. 7, 7. 67 times 7. 7 times 7, 49. 7 times 6, 42. Plus this 46, 4, 69. Absolutely. That's what we have been looking for. So that's 4, 6, 9. So the square root of 369 is 37. So we're going to be using our formula method right away. So we've seen what we're going to use. We're going to be using this. 49 times 7, 3 for the 3 is what is best after this. So quickly, A is 1, B is 1, and C is minus 3 for the 2. So don't forget the formula method, minus B plus or minus, square root of discriminant over 2A. You've gotten the discriminant already as 1, 3, 6, 9. So minus B minus 1 plus or minus square root of the discriminant 1, 3, 6, 9 over 2 times A. A is 2 times 1, which is 2. So that's minus 1 square root of, or square root of the discriminant, that's 37 over 2. So what do we have? The next thing we have is minus 1 plus 37. Minus 1 plus 37 will give us plus 36 over 2, or minus 1 minus 37 give us minus 38 over 2. So what's going to be the value of x? The value of x is 2 in 36 is 18, or 2 in 38 is minus 19. Absolutely correct. Now if we substitute either of those values into this, then we're going to usually get 0 modulo 49, as simple as that. So x is 18 or minus 19. So we've come to the end of this very lesson. As you can see, this very final question was quite very tricky, but very solvable. So I'm very sure that a good number of people solved this very question right. So we've come to the end of this very lesson. We're done with everything that has to do with equations under modular arithmetic. In our next lesson, we're going to be looking at the final part of modular arithmetic. We're going to be looking at the various applications of modular arithmetic, how we could use modular arithmetic to get the remainder of various very large divisions of numbers. We're going to be looking at CRT, Chinese remainder theorem. We're going to be looking at a whole lot of stuff, Fermat-Little theorem, and so on and so forth. So if you've gained one or two things from this very lesson, I would love you to please give me a follow on Facebook at Revelation Hub and subscribe to the very channel at Edge Mosaic, and please share the lesson also with others. See you in the next lesson. Thanks and bye for now.